This is the video record for probability and stochastic process homework 10, and this is the video record for problem 2, question 2. The question asks us to find from the lecture notes, collect the definitions of properties of these stochastic processes, and there are in total 7 which are required stochastic processes. The first is a wide sense stationary process, and its definition is a stochastic process when its mean is a constant and its autocorrelation is a function of time difference, which is equal to tau equal to t1 minus t2. And the second is an independent increment process. The definition of an independent process means when x of t1 minus x of t2 and x of t3 and x of t4 are non-overlapping intervals, are non-overlapping intervals on the time intervals, which can be t1, the interval of t1, t2, and interval of t3, t4. And so these two values are independent on these non-overlapping intervals. And the third is a Markov process. A Markov process is if a process x of t has a past and has no influence on the future when the present is known. This entails that the process is only dependent on the present and not on the future, not on the past. And the fourth process is a normal process, which is also called a Gaussian process. This process is when x of t is said to be normal if the random variable x of t1 and x of t2 and to the x of tn are jointly normal for any n, and any t1 and t2 and to tn to tn. So, and this value of fx, where we take the which is relative to x1 to xn, also t1 to tn, which is equal to 1 over the root of 2 pi and the nth root of the detergent of c times the times e to the degree of minus 1 over 2 times x minus eta, take transgender, and also the c minus 1 to the degree of minus 1 times x minus eta, and where we can also find the definition of x, which is equal to x1 to xn as a matrix, as a n by 1a matrix, and x is also equal to x of t1 and x of t to x of tn times eta, and this is equal to the means of x. And we can also find the covariance of x is exactly equal to the expectation of x minus eta times x minus eta take transverse. And the fifth question is what is a strict sense stationary process? If a process is said to be a strict sense stationary process, if it has statistics is not affected by a shift at the time axis, it means that the process has no relevance to the time, and it's always strict sense stationary. And the sixth is what is a white noise? A white noise is when a Wiener process Wt, if we wish to discuss its derivative v of t equal to take the derivative of v Wt over dt, and we can have its means equal to 0, and its and its correlation should be Rv of t1 and t2 equal to alpha times sigma of t1 minus t2. And a stochastic process V of t is said to be a white noise if its its means is equal to 0 and exactly its covariance is equal to Q of t, which is like a its fixed value, and times sigma of t1 minus t2. And the seventh is mean ergodic process. This is a stochastic process which has a limit value when t is equal to infinity, and we take the limits of 1 over 2t and take the integral from minus t to t of x of t, and then it's exactly equal to its means. and it's also in the mean square sense. And in this stochastic process is called mean ergodic process. And we can also find the eighth problem where Martingale's process is defined by this equation where it's x means of x of t when x of s is equal to x1. It's exactly equal to x of s when it is strict sense stationary. So it's like a more strict version of a SST. This is the end of this video record.